boy, that, at that point, I was living in my van. I had sold everything, all my ski equipment, all my stuff. I moved into a van so I could sponsor my research. And I moved down south so I wouldn't have to eat so much. And so I was doing this in my van, and I was so excited. I mean, this was better than sex. I mean, I didn't have a girlfriend at the time, And so it was just beautiful. It was metaphorically beautiful, but in the physics of what I was trying to achieve, it was exactly going in the direction I wanted it to go. And I realized that the vector equilibrium had to be fundamental to the structure of space, of the class. Why is the vector equilibrium the only geometry in full equilibrium in all vectorial possibility? Let me show you. If you have a vector going in one direction, and that vector has a certain length, we'll call the length of the vector its force. So longer it is, stronger it is, shorter it is, weaker it is. Okay? In order to get equilibrium, you would have to have a vector in the exact opposite direction with exactly the same length. But that's a weak equilibrium because you'd have to nail that vector so that it would be a perfect alignment here. Otherwise you would miss equilibrium, and any forces pushing down in any other direction would break the equilibrium. It's very precarious. So how would you increase stability? You'd probably add vectors at 90-degree angle from those. Now you increase equilibrium, right? However, the edge of your geometry has longer vectors than the vectors to the center. Because they're longer, they're stronger, and thus your geometry explodes. It doesn't work. What would you do to try to correct it? Probably add vectors at 45-degree angles from these other ones. But if you did that, then the edge vectors are shorter than the vectors to the center. The geometry implodes. You still don't have equilibrium. So what's the solution? The solution is the hexagon. Because the hexagon has edge vectors that are the exact same length as the vectors to the center. It's the only geometry that does that. So now you have equilibrium. And what does that look like in 3D? It looks like a vector equilibrium. This geometry here. Oh. Okay. Vector equilibrium. It's 8 tetrahedrons pointing inwards. Now, this can be seen as well as 4 hexagons intersecting each other. Do you see that? The red one on the edge, there's a blue one at the equator, and then 2 ones intersecting in the middle. Everybody see that? There's a red one on the edge, an hexagon on the edge. 4 hexagons intersecting, creating equilibrium at the center of singularity. And note that there is 12 vectors radiating from the vector equilibrium. So there's 12 vectors radiating from the center, and there's 12 edge vectors, 24 vectors. These numbers are found in most ancient civilization texts. 12, 24, and so on are found everywhere. The 12 angels with singularity in the middle, the 12 apostles, with Emmanuel in the middle, the singularity, and so on. The 24 elders in Kabbalistic traditions, and so on. So I was really amazed that I had found this, but my geometry was still out of equilibrium. Meaning, on this geometry of the two isotropic vector metric, the vector equilibrium in the middle had all of its octahedrons filled. That means that when the vector equilibrium is in the middle, the pyramidal structures are completed with octahedrons. But the edge octahedrons were incomplete. So I still had a symmetry. So I went back to the drawing board, back in my van, trying to, I've got this in my brain, and I'm noticing that some of the faces of the octahedrons are not covered. So it's asymmetric. So I decided I have to keep adding tetrahedrons till I gain symmetry. So I kept on adding tetrahedrons, and to cover all of the faces, I had to add 24 tetrahedrons to the ones that were already there. So this is one isotropic vector metric is 20. The other one is 20. That's 40 plus 24. 40 plus 24 was 64 tetrahedron metric. The 64 tetrahedron metric is a match to many, many things. I'm going to give you a hint. There's 64 codons that generate the 20 amino acids of your DNA structure. Okay? Now, when I found the 64 tetrahedron grid, then I realized that that was the quanta in which symmetry was present everywhere and equilibrium was truly generated at the center. But what got me really excited is that I realized what I had built. What I had built was a fractal structure, just like the 2D fractal structure I showed you at the beginning, but this one in full 3D spherical coordinates. The only true fractal 3D spherical coordinate that you will find. Can everybody see the vector equilibrium on the inside and then the vector equilibrium on the outside? This continues to grow to infinity. And I could see that the inside vector equilibrium, its radius is exactly half the radius of the one on the outside. So the geometry grows in fractals, but not only does it grow in fractals, the fractals are perfect octaves. You see? And so I got really excited. It's like, oh my God, here it is. The structure of the vacuum. Equilibrium to infinity. Infinitely big to infinitely small. And then I noticed further that how this was constructed is constructed this way. Let me see if I can let go of some of this stuff. Actually, I'm going to leave that. I realized what I had built. I had built a matrix based on 8 star tetrahedrons, each having 8 tetrahedron in it. Okay? All coming together towards the center to generate the star, the 64 tetrahedron grid. But when it did, the 8 stars coming together. Okay, here you're only going to see 6, plus the 1 in front, and then there's 1 in the back you won't see. So the 8 stars coming together generate the vector equilibrium in the middle. Why is this significant? 8-star tetrahedron is made out of 8 tetrahedron pointing outward, radiation, coming together to generate the vector equilibrium, which is 8 tetrahedron coming towards the center, generating contraction. So now, not only did I have found the geometry of equilibrium, but I had found the only fractal 3D metric, and it generated expansion and contraction. Exactly all the axioms I had placed for myself when I started this investigation of the geometry of space. I was so excited. I'm still excited. I was doing this in my brain. I didn't have a computer, and I confirmed it later on computers. But I was like, oh my God, this is so awesome. And then something really weird happened. I knew I had the fundamental structure of space. I knew, I was definitely seeing. Now realize, you guys, if we truly have the fundamental structure of creation, then technology that's based on this information is going to tap directly into an infinite potential of energy, infinite potential of gravity, infinite potential of rejuvenation, regeneration, and so on. You're talking serious change in our way of doing technology. So I was really excited. And then a bunch of people in England called croppies. Those are people that measure and photograph crop circles. Okay? Now, I know you guys, crop circles, There's scientific papers that were just published in peer-reviewed journals about crop circles, because many of them are not being able to be explained by people going in the fields at night and stomping around, Doug and Dave drinking moonshine and freaking everybody out. Some of them are not easily explained, and actually papers have just been published in peer-reviewed journals saying that this might be a new source of energy. But the croppies that I'm talking about decided in 1997 that if somebody was trying to talk to us through the crop circles, maybe we should talk back. So they went in the crop circles and they wrote in big letters by stomping around with their boots, what do we need to know? Good question. And the next crop circle that occurred was the largest crop circle to date at that time. And it's this one. Have we seen this somewhere? This is everything we've been talking about this morning. What do we need to know? Well, that's really nice. They give us this. They even made it in a way that's not reproducible by Doug and Dave drinking moonshine. Because all the hay is woven in a way that it makes effects of light and shadow that gives the vertices, the edges of 3D tetrahedron. That